Close your eyes for a moment. Think about the last time you watched a candle burn down to nothing. The flame narrows, it flickers, and then it's just gone. Smoke curling upward, a thread of it drifting through the air, and then silence. The room is unchanged. You are unchanged. But something that was there is no longer there. That moment has always felt like an ending. And we have been trained, every one of us, to see the universe the same way. Things begin. Things end. The candle burns. The star dies. The universe itself one day grows cold and dark and still. But here is the thing no one tells you when you first learn about the death of the universe. We do not actually know what happens after. Not in the vague philosophical sense. Not in the, well, nobody really knows anything sense. In the precise, rigorous, deeply uncomfortable sense. The equations that have explained nearly everything in our physical reality. The same equations that predicted black holes before we ever saw one. That told us the universe was expanding before we could measure it. That gave us GPS satellites and nuclear reactors and the screen you are watching this on. Those equations go quiet at the end. They get to a certain point, and then they stop. The final moment of the universe is a wall, and no one has yet figured out what is on the other side of it. But to understand why that question matters so much, you first have to understand what the end actually looks like. Because most people have it completely wrong. When you think of the death of the universe, you probably picture darkness, absolute cold, everything frozen, still, empty. That is one possibility. Scientists call it the heat death, and it is genuinely bleak. In roughly 10 to the 100th power years, that is a 1 followed by 100 zeros, every star will have exhausted its fuel. Every black hole will have evaporated through Hawking radiation. Every particle will have settled into its lowest possible energy state. The universe will reach what physicists call thermal equilibrium. No temperature differences anywhere. No gradients, no energy flow. Nothing to drive any process of any kind. To feel how large that number is, consider this. The current age of the universe is about 13.8 billion years. Written as a number, that is roughly 10 to the power of 10. The heat-death timeline is 10 to the power of 100. That is not 10 times longer. That is not 1,000,000 times longer. It is longer by a factor that has no name in human language. So that is the picture. A vast, cold, featureless dark. And the question that keeps physicists awake at night is not whether this will happen. It is what happens after that. Let us start small. You are made of atoms. Every atom in your body has been around, on average, for billions of years. The iron in your blood was forged in the core of a star that exploded before the sun existed. The oxygen in your lungs is older than the earth. You are not a person living in the universe. You are a temporary arrangement of ancient matter, briefly conscious, in a 13.8 billion-year-old story that is still being written. That story operates according to a set of rules. And those rules, as best as we can determine, are not negotiable. The first law of thermodynamics says energy cannot be created or destroyed, only transformed. The second law says that in any closed system, entropy, which is a measure of disorder, always increases or stays the same. It never spontaneously decreases, ever, under any conditions. This is not a tendency or a statistical likelihood. It is a law more ironclad than any government, more universal than any culture, more consistent than any human institution has ever been. What this means, practically, is that the universe has a direction. Time flows one way, because entropy flows one way. The past is where things were more ordered. The future is where things become less ordered. The egg does not unscramble. The smoke does not re-enter the candle. The heat does not flow back from cold to hot. And the universe, taken as a whole, is moving relentlessly toward maximum entropy, toward the state where no more ordering is possible, where every joule of energy has been fully spent and spread and equalized. This is the arrow of time, and it points always toward the end. Now, let us step back further. The observable universe, the sphere of space from which light has had time to reach us, is about 93 billion light-years in diameter. 1 light-year is roughly 9.5 trillion kilometers. A single light-year. The observable universe contains at least 2 trillion galaxies. Each galaxy contains, on average, hundreds of billions of stars. Our Milky Way alone holds somewhere between 100 and 400 billion stars, and the Sun, which feels enormous from where we stand, large enough to fit 1.3 million Earths inside it, is a perfectly average, unremarkable star. Please sit with that for a moment. You are standing on a pale blue dot, orbiting an average star in the outer arm of one galaxy among 2 trillion. And all of this? Every single star, every planet, every nebula, every black hole in every galaxy. All of it is moving toward the same thermodynamic end state. Here is the gut punch. When the last black holes evaporate, and they will because Hawking radiation slowly bleeds energy from them over unimaginable timescales, the final one to go will be the largest. A supermassive black hole the size of the one at the center of a giant galaxy. It will take roughly 10 to the power of 100 years to fully evaporate. When the last photon of Hawking radiation from that final black hole crosses the horizon of the universe, there will be no matter. No radiation, no difference in temperature between any 2 points in space, and no process of any kind will ever happen again. Anywhere, for any reason. The last event in the history of the universe will occur, and then there will be no more events. Not for a long time, not eventually, not ever. Because time, without events, without entropy increase, without any change, time itself may lose all meaning. This is where the physics gets uncomfortable. Because here is the question the equations cannot answer. In a universe that has reached maximum entropy, in a state of perfect thermodynamic stillness, is that state truly final? Or is it, somehow, a kind of beginning? The laws of physics are time-symmetric at the microscopic level. If you filmed the collision of 2 particles and played it backward, you could not tell which direction was forward, and the arrow of time emerges at the large scale from statistics, from the overwhelming probability that high-entropy states vastly outnumber low-entropy ones. But at the bottom of reality, at the quantum level, time has no preferred direction. Which means, and this is the part that genuinely has no resolution yet, that a universe at maximum entropy, given infinite time, might spontaneously fluctuate. Quantum mechanics, taken seriously, tells us that in a perfectly empty, cold, maximum entropy universe, random quantum fluctuations can still occur. Most of them would be unimaginably small. But over truly infinite time, and remember, we are now past the 10 to the 100 mark, past all events, in a duration with no name. Eventually, a fluctuation of arbitrary size becomes not just possible, but statistically certain, where this idea is called the Boltzmann brane scenario. Named after the physicist Ludwig Boltzmann, who first grappled with it in the late 19th century. The logic is horrifying and airtight. Given infinite time and a non-zero probability of any quantum fluctuation, it becomes statistically more likely that a random fluctuation would spontaneously produce a fully formed, conscious brain, complete with false memories of a life never lived. than that the entire low-entropy early universe we observe would have come into existence by chance. The fact that you are reading this, that you have a body and a history and a world around you, suggests you are not a Boltzmann brain. But the theory does not go away just because it is unsettling. So we are left here, at the edge of the final moment, with a question that physics has posed and not yet answered. Then what happens in the infinite time after the last event? Pull all the way back now, further than the galaxy, further than the observable universe, further than the timescales we have been describing, which are already so vast they have dissolved all human intuition into silence. Consider what it means that we are here, inside this story, asking this question. Every structure the universe has ever made, every galaxy, every star, every mountain range, every storm, every cell, every nervous system, every moment of music or grief or laughter or discovery is a temporary eddy in the flow of entropy. Complexity is what happens when energy moves from a concentrated place to a diffuse one. Life is what happens when that movement becomes, briefly, organized enough to model itself, to look back, to ask why. The universe does not require consciousness to proceed. Entropy increases whether or not anything is watching. The stars will burn and die and scatter their metals across the void, whether or not there are eyes to see them go. The final black hole will evaporate into a universe that may contain nothing capable of registering the event. And yet, here we are, 13.8 billion years into a process that did not need us. And here we are, having built the mathematics to describe our own irrelevance, having looked at the fossil light of the earliest galaxies, having calculated the temperature of the cosmic microwave background radiation to 4 decimal places, having named the end of time and laid out its mechanism and sat with the quiet dread of understanding it. There is no law of physics that predicted this. Intelligence is not a feature written into the equations. Curiosity has no thermodynamic necessity. The fact that matter arranged itself, here, in this backwater of a middling galaxy, into something that can comprehend entropy and write equations about the heat death and make a video asking what lies beyond the final moment. That fact is nowhere required by the laws that govern the universe. It happened anyway. Now, back to the question, what lies beyond the final moment? The most rigorous answer physics currently offers is, we do not know. The question may not be well formed. In a universe at maximum entropy, in the absence of any events, the concept of beyond may not apply. Time, as a meaningful dimension, may require change. Without change, there is no before and after. There is no beyond. But that answer is not fully satisfying. And physicists know it. Because the same quantum mechanics that governs everything we have ever measured tells us that a vacuum is never truly empty, that even nothing has structure. The vacuum of space has a ground state energy. Virtual particles flicker in and out of existence in the heart of apparent emptiness. The universe at maximum entropy may be the closest thing to nothing that physics allows. But it may not be nothing. And if it is not nothing, then something is still there. And something, given enough time, can become something else. Some cosmological models suggest that a maximum entropy universe is structurally identical to the conditions that preceded the Big Bang. That the void left by the death of one universe is indistinguishable from the fertile emptiness from which another one could emerge. Not by any cause we can name. Not by any mechanism we can currently write an equation for, but by the same blind statistical logic that makes quantum fluctuations inevitable given infinite time. This is not a proven theory. It is a hypothesis at the edge of what mathematics can currently reach. but it is a serious one, held by serious people. And it leads to a picture of the universe that is neither comforting nor despairing, but something much stranger. A picture in which the end and the beginning are not opposites, but synonyms. In which the death of everything is simply the conditions required for a new everything to eventually, quietly, without witness, begin. You are made of matter that was forged in stellar explosions. You are the universe observing itself across an incomprehensible gulf of time. And one day, the matter that makes you will be scattered, or when the matter that is scattered will become something, and that something will become something else. And on a time scale that reduces the entire current age of the universe to a rounding error, something will happen that we cannot yet name. Physics has a wall. And somewhere on the other side of that wall, something is happening right now. We just cannot see it yet.